Okay. Hi everyone. So my name is Haroen. I'm founder CTO at Luzmo. Okay. What I want to present to you today is the following. So we started our ClickHouse journey in 2018, so quite early, and I want to guide you a little bit throughout our journey, why we decided to use it and how we are using it today, but also how it has driven some innovation in our company. So most of the features that we add to our product, of course, come from client needs and sometimes angry yells of clients. Please add this feature, and then we do. But in some cases, it also comes from the technology itself, like where we see if we use this, perhaps we can build something just that is taking it even better or solve a problem that many as well. But to get started, what is it? So Luzmo is a data visualization platform that you can use to build dashboards and data products and give them to your clients. So we are strictly embedded in other software offerings. Can be by software as a service companies, but we also have banks as customers, telecom operators, etc. We're also building software, also giving data to our clients, or even monetizing data like location data, where people are connecting their mobile phones to cellular fasts, etc. So just to very quickly show you the interface, it's slightly more tangible. What I can do here is to quick there once. To work is, for example, connect to ClickHouse. We are a ClickHouse event, so let's just connect to the playground of ClickHouse. It's a nice environment if you don't know it yet. So it's a free server that you can use
for your own needs. There is some quota limitations, etc. But we'll select here a set which is about flight data and how on time airlines are at various locations. So we made a connection. We added the data set to the platform. Now we're going to very quickly design a dashboard using this drag and drop interface, where you go into your set, for example, select, let's say, the departure delay in minutes that we see, for example, by state. I'm just freewheeling a little bit here. And now we are going to take an average here, and perhaps we want to sort this a little bit. Voila. So looking at, for example, the states, the 10 most the states where you are most likely to incur some delays. So you see that it can be built very quickly. And we can add some time data here. Let's do it by quarter. Look at the total number of flights. We can do that this way and do a row count here. And all of these charts are immediately linked to each other. So I can go to New York, and I'll see how many flights, for example, were there in New York since 1988. So you see the interface is relatively snappy for these queries while we are working with, let's try this out. How many data points are we using here in ClickHouse? So we're working with 204 million rows. So it's pretty impressive. Not our achievement in this case. This is mainly ClickHouse's performance that you are seeing. Now, how is this different from a BI tool? Well, it's different because you can very easily embed it and make data products out of it. You can do this with the drag and drop editor, but you can also do this in code. So you can build data applications using what we call flex components, where you connect different charts on the page, different interactive components, and they can be filtered automatically based on who's looking at it. They can be personalized, etc. But that's not the focus of today. The focus of today is more on the data side and innovation. So Luzmo is a federated platform. So it means that we are always going to grab data from your sources in real time. So you can connect all kinds of databases, relational databases, data warehouses, like ClickHouse, of course, but also Snowflake, Redshift. And you can even use different sources at the same time that are integrated in real time when you are loading a dashboard. Now, in many cases, our clients actually wanted us to go further and also be responsible for storing the data. So we also offer a part where data is actually stored on our site, where you can upload CSV files, etc., for proof of concept, or for those companies where Excels are still being used. There's API push, so you can push data points via the API, and there's Warble. I'll tell you a little bit about that. So where does ClickHouse come in here? In 2018, we added a connector to ClickHouse, but very soon we also decided to run our entire internal warehouse on ClickHouse. So all the customer data that is coming into the platform, we store it inside a ClickHouse that we manage, and we migrated to ClickHouse Cloud over the years. More about that in a second. We're also using it for usage analytics, for usage logs, and all kinds of data keeps being added to this site. Now, many of our clients a couple of years ago had the same issue essentially. If you build a dashboard and you add, let's say, 50 or 100 different charts to it, almost all BI platforms or chart tools or whatever you want to call them are going to launch 50 to 100 queries to your data sources. And even a platform like ClickHouse, which is pretty good at answering queries, can choke on that kind of query volume, especially if you give it to all of your clients and they are all looking at that data at the same time. So one of the things where we thought, hey, can't we find a solution to that, is that we built a query engine, essentially, that we wrote it in Rust. It's been up and running for a couple of years now, where essentially we're looking at that dashboard that you've created, and at the moment that you're querying it, we are trying to find out how can we statistically optimize all of those queries that are happening, and how can we answer them with the lowest total number of queries and expected overhead to actually service this entire dashboard. And that could mean that a dashboard that's normally using, for example, 2 different data sources, one ClickHouse and perhaps a Google Drive data set that is linked with 100 widgets, might actually be serviced by 2 or 3 queries in total. Which is a lot faster to load. So we are doing those queries, we get intermediate result sets, and we're further refining those in real time into the charts that, into the data that the charts themselves need. So in our tests and on real customer use cases, we see sometimes up to 70, sometimes even more times loading time improvements when this query engine is used. A second thing where many customers came to us was, hey, okay, it's all nice that you connect to all of these warehouses, but we don't have a warehouse yet. We are still storing data in Postgres. We have built our core application, and all of our main platforms transactional workloads, select, loading details, perhaps loading 50 records, doing continuous updates and deletes. Those are happening on the database. Now we have our reporting use case. And we don't want to invest yet in, for example, a ClickHouse or a different kind of solution here. For that, we decided to build Warp. So Warp is a synchronization layer where you click a button in the interface, and the entire set gets synchronized into our multidimensional warehouse, so ClickHouse. So it's essentially a ClickHouse as a service, but operating at the level of individual data sets, very easy to activate. And of course, that's a lot faster than doing those queries on even a moderately loaded operational database. Typically, it even makes the application itself faster because you remove the conflicting analytical workload from it. So that's really an area where ClickHouse allowed us to roll out a new feature pretty quickly. We did run into some issues though with ClickHouse, most of which were solved by us getting a better understanding and ClickHouse releasing more and more features to help with various use cases. One of which is that we initially ran our own ClickHouse cluster and had a lot of issues because you also needed a Zookeeper cluster to keep the distributed state of the cluster. Yeah, that wasn't a great fun thing to maintain. That caused many incidents and lost, nightly pages of incidents that happened. And so we decided to migrate to cloud when it was launched, I think in 2023, because I think it makes sense to not be responsible for that part of the workload. Another one was where we are initially creating a separate ClickHouse table per dataset that customers upload to the platform or per set that you warp. This is something that's a little bit unique, not necessary, but a little bit specific to our use case, that we don't know the data schema of the sets that our clients upload to us. We only see it when the set arrives and we need to immediately store it. This is a very bad thing to do. This is something where ClickHouse is absolutely not optimized. So once you push it beyond, let's say, 10,000 different data sets, you already notice that the load on those servers is going to go up quite a bit because of all the threads and background processing, etc., that's happening per table, per collection, where that is happening. And once you push past, let's say, 50,000 or 60,000, as we were, you're looking at sometimes at startup times of an hour before a server actually gets online after you start or reboot the cluster. So that's quite painful. Nowadays, it's better. They have lazy loading. But mainly, we switched to something very stupid, which is just putting everything in a single table, essentially. As stupid as it sounds, where you don't have specific columns anymore, but just a map of all the possible columns, this works surprisingly well. So the great read performance of ClickHouse really helps you out in some cases to iron over some of these issues. A similar one is this. So when we were updating datasets, so a new version of the data arrives, and you want to essentially, upload that one, and once that succeeds, switch to using that set instead of the previous one. You obviously don't want that process to be somehow aborted halfway. Imagine that you're loading your new data, and suddenly you encounter a row that is, invalid, or the network connection drops, or whatever. Of course, the previous data should be retained, and all of the queries should still go there. So you essentially want to swap versions at some point. Initially, we took the wrong route to try to make this somewhat atomic by loading into a temporary table and then loading the temporary table into the final storage, or renaming the tables to switch from like an A and a B version. But again, this is a stupid thing to do. The pressure that it creates on the system, all of these data definition changes is really painful, and those renames start failing, which means that you need a back process and a rollback process for that operation failing, etc., etc. So it spirals pretty quickly. Well, it's very easy to actually solve it. You just insert the new data in a table with a kind of batch ID, and you switch to using, you just filter out, for example, the data that you know is faulty. So you only include data where you know that it should be part of your set. You don't even need to clean up that faulty loaded data, essentially. It's the reading performance is so good that, skipping out that information at runtime, the performance cost of that is very low, so you just clean it up at a later stage when you have time. You do it asynchronously. We also had some issues with dates that are older than 1600 or later than 2200. Nobody uses those, right? But yeah. So just as an example of where we are using ClickHouse and trying out new things, some of which get to production, some of which don't. So an example here is a technology demo that we made called InstaChart, where the idea is that you can just draw a dashboard essentially on a piece of paper. So I'll hold it before the camera so you can see it. So you have here an attendee report where you see the interest per speaker for ClickHouse, Luzmo, Landsweeper, etc. The number of bad jokes, obviously highest for Luzmo, and the beer consumption over time. So I'll try to position this before my camera. I'm going to generate the dashboard. Voilà. So what we are doing here is using the visual GPT models to essentially scan this document and turn it into an intermediate representation of a dashboard that we then transform into an interactive Luzmo dashboard. So what happened here, I see there's a couple of spelling errors here, but you see the attendee report, you see data, it made it, it switched it to jokes over time apparently, and we have our bad jokes distribution. So essentially what it did is looking at that dashboard, creating also a data set on the fly, so a demo data set about the problem domain about which you are making your dashboard here, loading it into ClickHouse, generating an interactive dashboard on top of that, and then visualizing that. What's the relevance? Why am I telling this? It's another example of where we are using ClickHouse as a motor for innovation in our company. So recently we started using ClickHouse as a vector store. And again, this is quite easy and unexpected that it works as well with so little work as it actually does. So what we are doing here is creating a table with embeddings. So the idea is that you're going to encode pieces of data, pieces of textual data, for example, as and so you're projecting them into a vector space to represent them in a standardized way, where you hope that concepts that are very similar have representations that are in that vector space close to each other. So you're going to store those vectors in ClickHouse, and you define a vector similarity index on top of them, because this is not strictly necessary, but if you want to go and search for close vectors and you still want it to perform well once you pass 1 billion vectors, you want to have some kind of spatial indexing on top of this. And then we're going to call, for example, Olama, so a local Llama 3 model via the Olama tool to actually, let's say, embed a piece of data. In this case, we have a product description about a tasty rubber pizza that we want to embed so that we can later use it in an application. And we're going to store that embedding. And once we are past that, we, for example, want to search all relevant documents that we stored given a certain search query by taking a cosine distance of what we were searching for versus all of the documents that we have stored. So you can, of course, use a separate vector store for this that's optimized for that. But again, ClickHouse's arsenal of tools is pretty large, where it becomes feasible to do this for even relatively large data sets quite quickly. So how are we translating it into new features? This is something that we are going to launch on Thursday. This is a new product that's coming out called Luzmo IQ. And the idea is that it's a data assistant that you can use standalone, but also embed within your products. So you can, for example, add a kind of chatbot, but also a search bar or an executive summary about a data set or that your customers want to interact with, and put it in your product. And we do this as a set of components, as usual. So you can decide if you want a full assistant or just the answer section or just the executive summary part. And you can ask it questions about your sets, which not only look at the metadata, but can actually analyze the question that you ask, translate it into queries, perform those queries, analyze the data that comes back, and represent that to the user. So for example, here we have a kind of e-commerce setting with e-commerce data sets, and we want to, for example, analyze, let's say, the delivery speed of my products. So in most cases, we are first going to do an analysis step where the assistant is going to break down that question and find in the embedding store which are relevant data sets that would possibly answer this query. So automatic data set selection is built in. It's going to generate queries and execute them using our query engine, potentially using WARP, getting it from multiple data sources potentially. And then it's going to analyze the data that comes back and transform it into like a user-readable summary. So in this case, we see delivery speed, that the product electronic concrete sausages, that's something I want to buy for Black Friday, had the fastest average shipping time. We see that the sleek bronze computers have noticeably slower shipping times. The chart it selected, not the best one, I admit. That's the problem of live demos. But what you can always do is still adapt, so you can see which kind of what kind of chart it generated. You can still adapt what kind of choice it made, or give feedback, of course, that some of the charts that were generated were perhaps not the best. So that's something that's coming Thursday, and it's built on various innovations that we have rolled out over the years, where ClickHouse definitely is also a big part of what we were able to do. Voilà.